Hi ladies and gentlemen, today we're going to be evaluating piecewise functions graphically. Something new we haven't talked about before is piecewise functions. So the first thing we're going to do is to evaluate them from a graph. So the first thing we're going to do is actually define what a piecewise function is so that you guys know. A piecewise function is a function made up of separate functions on different parts of its domain. And remember, domain is the x values, right? That means depending on what x values we're looking at, the function will look like different equations. So we have both a picture and an equation, so you kind of know what they look like. I'm going to change the highlighter here. So if you notice, I have three different lines here. I have a piece of this line, I have a piece of this line, and I have a piece of this line. Hence the name piecewise. I have pieces of different functions, and I put them all together on one graph. Hence, so therefore it's called a piecewise function. It's just not one function together. It's different pieces of a function. And if you look at the equation, look, I've got three different equations here. See that? Three different equations. And each one of those equations matches matches one of the ones on the line. And actually I'm going to color code them for you so you can see which ones go with which. The top equation goes with this one because it says right here, if x is less than -5. So when x is less than -5, it's this line. And then right here, the one that's at -2 is between -5 and 3. And then we've got this last one that's 2/3 x minus 9. And it's when x is greater than 3. So if you can look, right, the line starts at x equals 3, and then it's all the numbers that are greater than 3 is that line. So those are the pieces that go with each other, and that's what makes a piecewise function. It's different functions or different lines, different types of graphs all together on one graph or one equation. So that's what we're looking at today. So today we're just going to evaluate them graphically. We're going to give you an x value, and I want you to tell me what the y value is. That's all. That's all we're going to do. Okay, so we have a couple graphs we're going to look at. So here's the first one. We've got g of x here. So remember, this is my x value. Whatever's inside the parenthesis is my x value. And then I'm going to just find out what the y value is. So I'm going to go to -5. So on my graph, I'm going to go to -5. Well, here's -1, -2, -3, -4, -5. And then I want to go up to my graph. And this is the point. Well, what point is that? At -5, my graph is at 1, 2, 3, 4, at 5. So g of -5 equals 5. So I want to know what the y value is. So now I'm going to do the same thing for -4. Okay, so -1, -2, -3, -4. And there's my point at 4. We're going to do the same thing at 0. Well, here's 0 right here. And look, I have a point here, and then I have a point here. I want to show which one would be the right point. Well, what does an open dot on my graph mean? We've kind of graphed already when we were talking about inequalities. An open point means not included, right? So this means not included. So that's not the point I'm looking at. If it's solid, that means it's included. So this is the point I'm looking for. So at g of 0, right here at 0, my y value is also 0. Okay, so now we're going to go to the next one that says g of 2. So I'm going to go to x equals 2, 1, 2, and down my point is at 2. And then I'm going to go to g of 4. It's 2, 3, 4. This one's open. So I'm going to go down to where it's closed, which is also at, oh, geez, look at that. It would be -2 because I went below, right? So -2. There we go. Already making mistakes for you guys. And then I want to go g of positive 5. So 1, 2, 3, 4, 5, and I'm going to go up to 1. Okay, so that's how I evaluate off of a graph. I have one more example, looking a little bit different here. Okay, so if you look at this, you can tell that I've got a linear equation. Highlight this for you. I've got a linear equation here and a linear equation here, and then I have a quadratic. Okay, it's okay, it doesn't matter, it's just pieces of the function that we're evaluating. We just want to find out where, as I erase this for you, where the y values are. Okay, so here we go. And we're going to just do the same thing again. So f of negative 5. So remember, whatever value is in here is x. They just happen to be pretty close to the same on these ones. And you might not have 5 or 6 values for each problem. You might only have 2 or 3 to look for, but whatever you need, you're just going to go ahead and look for it, and then write the equation, write the answer down in the near pod, and then you have a couple delta maths to do. So I'm going to go to negative 5, 5, and up takes me to 7. Okay, and then I'm going to do the same thing for negative 4. So at negative 4, I'm going to go up 1, 2, 3, 4, 5, 6. So I'm at 6. And f of 0, so where x is 0 is here. Where's my y at? So it is at 4. And then f of 2 is here. So where's my y at there? Well, that is 0. And then we have f of 3, which is here. Well, if I go up, it's open, so it's not included. So I need to go down, which is a solid dot, which means it's included. So that is at negative 5. And then at 4, I'm going up, and it puts me there, which is at 2. And that's all I need to do today. I'm just evaluating where the points are on the graph. Given an x, tell me what y is. Remember, if you have any questions, either email myself or Miss Gilpin, or talk to me in my discussion board if you're in my class. I'm going to have a discussion going for this. If you have questions, go ahead in the discussion and ask a question there. Email us in Canvas. We'll get back to you as soon as we can. Thank you guys. We'll talk to you soon. Bye.